Hello all, welcome to today's session. Today we are going to discuss VTU questions, problem based on Kirchhoff's current law and Kirchhoff's voltage law. The question number 1, find for the bridge circuit, calculate current in all branches and power supply by the source. This question they asked in July 2018 for 7 marks, July 2016 for 6 marks, July 2017 for 8 marks. This is the given bridge circuit. The total voltage is given, that is 150 volt, and then bridge circuit resistor value is given. Before entering into this problem solution, we have to note down one concept very clearly. Whenever a resistor is like this, the starting terminal and ending terminal, starting terminal I am naming as a plus and ending terminal I am naming as a minus. Whenever the current flow is from plus to minus, that is from higher potential to lower potential, we have to put the sign negative. That is called as a voltage drop. Voltage drop. So similarly, from this is the starting terminal I am naming as a plus and ending terminal I am naming as a minus. When the current is flowing from negative to positive, that is lower potential to higher potential, whenever it is moving from lower potential to higher potential, we have to put plus sign, and then it is called as a voltage rise. Okay, voltage rise. So in this, now we are entering into the solution. So the circuit diagram, just as given in the question, just I am naming this terminal as a B, C, D. Like this I am naming all this junction, and then I am making all the loop, that is loop A, B, D, A and B, C, D, B, A, D, C, A, all I am making is a clockwise direction. The current flow is clockwise direction. So I am naming this I1 as a main current. Whenever it is coming to this junction A, it is having two branches. So I am naming AB branch as a I2 current and AD branch as a I1 minus I2 current. Already we are aware of that. According to Kirchhoff's current law, incoming current is equal to outgoing current. So in this, I1 is the incoming current, I2 is the outgoing. So incoming minus outgoing current will get the remaining current in the branch AD. So I mentioned here I1 minus I2. Here the branch current in BD, it is I3, and then this current, that is BC, is I2 is the incoming, I3 is the outgoing. So I2 minus I3 will get in the branch BC. Now coming to the branch D, in this junction D, current from AD is I minus I2, current in branch BD is I3. So both are incoming current. So this is the outgoing current. So in this case, I1 minus I2 plus I3 will be there here. So while coming to this junction C, I1 minus I2 plus I3 current will flow towards this junction C, and I2 minus I3 current is flowing towards junction C. So if both are incoming current, so I1 minus I2 plus I3 plus I2 minus I3. So here I3 get cancelled, I2 get cancelled. Finally we are getting I1, what we consider as a input current, total current, that is your value I1 current. Now according to Kirchhoff's voltage law, in loop A, B, D, A, I am taking only the loop 1, that is A, B, D, A. So as already we discussed that when higher potential to lower potential, we have to put minus. Whenever from lower potential to higher potential, you have to put plus. You have to keep this concept in your mind. I am just naming the terminal plus minus, and then plus minus. It will be a plus and minus. So like this. So whenever the current is flowing in this direction, so in this is Kirchhoff's voltage law. Sum of voltage at any closed loop is equal to the input voltage. Same like that. So here this current, that is here the current is I2, and then resistor value is 10. So V is equal to IR. So it is from higher potential to lower potential. So we have to put minus, and then V is equal to I into R. I value is I2, R value is 10. So we'll get minus 10 I2 minus in this branch. In this branch the resistance value is 5. So here it is from higher potential to lower potential. So minus 5 I3. Again it is higher potential to lower potential. So we have to put it is not a higher potential to lower potential. This is the plus minus to plus, that is from lower potential to higher potential. So I have to put plus 20, but the current in this branch is I1 minus I2. So here minus 10 I2 minus 5 I3 plus 20 I1 minus I2. That is our equation. If you simplify, you will get 20 I1 minus 30 I2 minus 5 I3 is equal to 0. Equation I am considering this as a equation 1. Similarly in loop 2, that is B, C, D, B. Okay, in this loop, see here, in this branch BC, that is 16 ohms is there, and then I2 minus I3 current is flowing from higher potential to lower potential. So minus 16 I2 minus I3. Here also it is from higher potential to lower potential, but it is in opposite direction. So we have to minus here, minus into minus will get plus. So we'll get 5 I1 minus I2 plus I3 plus this branch, that is DB. In DB branch, that is the resistor value is 5, but higher potential to lower potential, but it is in opposite direction. Here also minus into minus will get plus. So if you simplify, you will get the equation 5 I1 minus 21 I2 plus 26 I3 is equal to 0. This is equation 2. Now we are going for the loop ADCA. Loop ADCA. In this, similarly if you move that, we will get the equation minus 25 I1 plus 25 I2 minus 5 I3, that is equal to 150 ohms. So we got the three equation. If you substitute in the calculator, in some other classes I will discuss about how to simplify, how to solve this equation using calculator. So in this, after solving this in the calculator, I1 we are getting minus 13.47 ampere, I2 we are getting minus 8.27 ampere, I3 we are getting minus 4.11 ampere. So the current value should be in positive. So our considering assumed direction is wrong. So we are taking all the current value as a plus. Now our aim is we have to find the current in all branch. So current in 20 ohms resistor is I1 minus I2. If we refer that circuit diagram, you can easily grasp it. That is I1 minus I2. We will get 5.18 ampere, and current in 16 ohms is I2 minus I3, that is 4.18 ampere. Current in 5 ohms is I1 minus I2 plus I3 is equal to 9.29 ampere. And then the power supply of the source is P is equal to VI. Total voltage is given in the circuit, and then total current is 13.47. If you multiply this, we will get P is equal to 2020 watt. So here V is given, I just we consider, and then we got this value. I hope you all enjoy this video. Subscribe the channel. Thank you for your listening.